Trapezoids are the last quadrilateral we're going to talk about before your test, which will be on Thursday. Okay? So trapezoids are the first quadrilateral that is not a parallelogram. Okay, so think about that. Parallelograms were the first shape, right? Opposite sides are parallel. Second day was rectangles, which were also parallelograms, just with right angles. Yesterday we had rhombi and squares, which were both parallelograms, just with other specific things. So trapezoid is the first quadrilateral that's not also a parallelogram. It's its own animal. So it's defined as a quadrilateral with exactly one pair of parallel lines. Not at least exactly one pair. So when we draw a trapezoid, we want a pair of parallel lines. Now notice I make them slightly different in length. That's because if they were the same length, I would have either a rectangle or a parallelogram. Okay? So I want to be careful. And there is a trapezoid. Okay? So one pair of parallel lines. Those are parallel. The other two sides are not parallel. Are you okay with that? Not parallel. Now the top and bottom in this case, but really the parallel sides we call the bases. So this is a base and this is a base. The top and bottom in this case. But if it were on its side, it would matter. The pair of parallel lines, we call them the bases of the trapezoid. The other two sides, the ones that are not parallel, we call the legs. So this is a leg and this is a leg. The base angles are defined as the two angles at the longer base. So this angle and this angle are the base angles. I'll call it BA. Base angle, base angle. So notice even if the trapezoid were upside down, you're still looking at the longer base to figure out the base angles.
So LA is the leg angle?
BA is the base angle.
And what's that one right there?
These are both BA.
Oh.
Aren't they the same?
Yes.
Okay.
But they're not the same measure. They're both called base angles. She just couldn't read my writing.
Oh, okay.
And then finally we have the median. The median is the line segment joining the midpoints of the two legs. So if we come up this leg halfway, there's the midpoint. And up the other leg halfway, there's the midpoint. And we draw a segment between them. That is called the median. Now what's kind of cool here is, notice the median is actually parallel to the other two bases. So even though it doesn't seem like there's any connection at all, these are at the midpoint, this segment will always be parallel to the other two segments. Okay? All right, so let's do a couple examples. It says in trapezoid ABCD, so again, the naming convention, ABCD, going around the figure clockwise. EF is the median. Notice it's marked parallel. It says find the measure of angle 1 and the measure of angle 2. So because we have all these parallel lines right here, notice parallel line, parallel line, parallel line, and we have one line crossing them. What is that line called?
Transversal.
Transversal. And so we've got angle pairs here. So for example, corresponding angles are congruent. So angle 1 must be what measure?
70.
Okay. Now how does angle 2 fit in here? What do we call angle 1 and angle 2? They're not alternate because they're on the same side of the transversal. They're same side interior. And what's special about same side interior angles? They're supplementary. So the measure of angle 2 would be 180 minus 70, which is 110 degrees. And that's, so angle 1 is corresponding, I'll just say CA, corresponding angles, and angle 2 are same side interior angles. And that's very common in one of these problems. If you're given a trapezoid with a median drawn, you know immediately that the base angle is the same as this angle formed by the median, and it's supplementary to this top angle. So notice this top angle right here and this angle right here will always be supplementary. Okay? Now just to be clear, our consecutive angles, so this one right here, C, is consecutive with D. Are they supplementary in a trapezoid?
Yes.
Well, add them up. Well, we don't know what this angle is doing.
But is it?
Let's say this one is 70. Okay? So if this is 70 and this is 70, they add up to 140, right? So they're not supplementary. So in trapezoids, consecutive angles are not necessarily supplementary. However, these angles will be. The top and bottom will be on both sides. So this plus this will equal 180. Okay? So just to be clear there. All right. So next figure. How are these two angles related?
They're supplementary.
They're supplementary. So top and bottom on each side. Notice top and top, not necessarily 180. Top and bottom on the same side, these have to add up to 180. And so we can write an equation. 9x plus 6 plus, you got it. And now it's just a matter of doing some algebra to solve that equation for x. So we've got 9 x's and 3 x's, that gives us 12 x's. We've got 6 and 4, that makes 10. So 12x equals 180. Subtract 10 on both sides. So we have 12x equals 170. So 12 times what number is 170?
85.
So how do we? So it's not a whole number, is it? So how do we figure it out? Calculator, and what do we do? But what do we do specifically right here? We divide both sides by 12. Okay. So x equals 170 divided by 12, which you said was 14.16 repeated.
No, it's like 1667, so 117.
That's 0.1666666666. It is. Press the up arrow and press enter. Just press the up arrow once, highlight your answer, press enter, it'll copy it down. The calculator has to round it to a 12 decimal places, but it actually goes on forever, non-terminating. Okay. All right. Next, we have a theorem. The length of the median of a trapezoid is the average of the two bases. So let's draw another trapezoid. So there's a pair of parallel lines. Notice one pair of parallel lines. The other two are not parallel. And nor is there any direct relationship between them. So I'm going to call the top here base 1 and the bottom base 2. When we draw our median, which remember it connects the midpoints of the two sides, the length of this median is the average of the lengths of the two bases. Now that is one of the least obvious things in this picture, meaning that there is no clear reason why this must be true. We're not going to go through the proof of it. You're just going to have to trust me on it. If you really want the proof, I'd be happy to do it outside of class, but just not take up the time in class. So base 1 plus base 2 divided by 2 gives us the length of the median. Okay?
Base 1 plus.
Okay, so the average of the bases. So imagine you have two grades, you want to find your average, you add them and divide by 2. We have two bases, we add them and divide by 2. It's very similar to what other formula that we've used before. It has something to do with this point right here. Midpoint. Remember the midpoint formula? We add the x's and divide by 2. Add the y's, divide by 2. Well, on this we add the bases and divide by 2. Okay, so take a look at example 3. Now, how is this trapezoid different? It's on its side, but notice the bases, again, are the two sides that are parallel. So what are the two bases of this trapezoid?
AD and BC.
So AD and BC are the bases. Even though it's on its side, and you would say, well, this is top and bottom. Yeah, you're right, but that's why we don't call it top and bottom. We call them the bases. So the bases are the parallel sides. So AD we're told is 19, and BC we're told is 23. It says, what is EF? Now, EF, remember, is the median. And on the previous page, we kind of had a formula. The median is equal to base 1 plus base 2 divided by 2. So EF will be base 1, which I'll call AD, plus base 2, which would be BC, divided by 2. So let's see here. EF would be, AD we're told is 19, BC we're told is 23. So 19 and 23 make 42. Divide that in half and we get 21. Okay. Now, what number is right in between 19 and 23? 21 is halfway between them. That's how averages work. It's going to be right in between the two numbers.
Can't you just like count it and find it?
Good question. So could we just count them and find the number in between? Sure, but if this were 22 and you got an odd number, it's not a whole number halfway between anymore. You'd have to worry about fractions. So, but for the most part. Or if these numbers, like let's say this was actually part of a right triangle, and this side was square root of 17, and this side was square root of 12. Right? Well, then it'd be really hard to pick a number right in the middle of square root of 17 and square root of 12. So, okay. So using the same drawing now, it says EF, rather than being what we found at 21, it's saying forget about the numbers, same picture, but different actual measurements, okay? So EF is 20, BC is 25. What is AD? Okay? So let's start off by writing down, we'll think of this kind of a formula, right? So the median is the two legs added together, or I'm sorry, the two bases added together, so AD plus BC divided in half. Now we know EF, we're told is 20. We want to find AD, so I'll leave that alone. And we know BC is 25. Okay. Now again, a lot of you guys, believe it or not, I think even without any instruction, you can probably figure it out without any algebra whatsoever. But that's really useful when the answers are nice whole numbers. But when they're not, and you don't have a process or a strategy to address, most of you will just stop and go, I don't know how to do it. So this is why, even though you know the answer is 15 already, the question is, yeah, but what if, instead of this being 25, what if it were 25.936? How would I do it then? Okay? So, what number divided by 2 would give us 20? 10 divided by 2 is 20. So 40 divided by 2 is 20?
Yes.
Okay. So you see how whenever I say it out loud, it sounds ridiculous when you say like 10 divided by 2 is 20? So that's what you should do in your head is think about it out loud. Go, let's see here. I want a number divided by 2. So 10 divided by 2 would be 5. Okay, that's wrong. As opposed to taking a guess, right? So think about it, guys. Think about it before you say something. So what number divided by 2 is 20?
40.
So this, if that were 40, we would have an okay equation, right? 40 divided by 2. So AD plus 25 must be 40. And now that's the common sense way of reasoning through it. You say, well, what number divided by 2? Algebraically, what do we do with the 2 and the 20 to make 40? Multiply. So remember, when we're dividing here, to undo division, we multiply. So algebraically here, we multiply both sides of our equation by 2. That's how we do it algebraically. So the 2 and this 2, they divide out. Because 2 divided by 2 is 1. That's kind of the idea. 2 times 2 is 20. So we're left with just AD plus 25 equals 40. So now how do we solve this? Again, algebraically. So we want to get rid of the plus 25. So we take away 25 from both sides. And so we get AD equals 15. Okay, so those are all for any trapezoid. Any trapezoid. And remember, what's the requirement for something to be a trapezoid? Exactly what? One pair of parallel sides. Now that throws off some people. Let me ask you a question. How many pairs of shoes do you have on right now?
One.
You don't have on 2 pairs of shoes? But you're wearing 2 shoes. But it's a
Together.
pair, right? So when we say a pair of parallel lines, how many lines are we really talking about?
1, 3, 2.
If I say a pair of shoes, how many shoes am I talking about?
2.
So if I say a pair of lines, how many am I talking about? 2. Which is why we can explain away, this is one pair of parallel lines. It's right there, those 2. Okay? That's a pair. Whereas in a parallelogram, we have 2 pairs of parallel. So, one specific type of trapezoid is called an isosceles trapezoid. Now, with triangles, what does that mean if it's isosceles?
2 sides.
Okay, 2 congruent sides. Well, guess what? Trapezoids are the same. Trapezoid with 2 congruent legs. So we've got a pair of parallel sides, and then these 2 legs also have to be congruent for it to be an isosceles trapezoid. So that's congruent to that. So you got parallel bases, right? congruent legs. Now, in an isosceles trapezoid, the diagonals are congruent. So this is congruent to this. Look at your picture really carefully after you've drawn your diagonals. I want you to be drawing these. And I want you to think about, don't yell at it, I want you to think about, do the diagonals appear to bisect each other like they do with parallelograms? Think about it. Look critically at what you just drew and say, do the diagonals appear to bisect each other? In other words, do they cut each other exactly in half like was true for parallelograms? It doesn't appear so, right? I mean, it looks like this side is longer than that side. Okay, so that's important. That's something that sets trapezoids apart from parallelograms. The diagonals do not bisect each other. Okay? However, the diagonals themselves are congruent to each other. So if I call this A, B, C, D, this is trapezoid A, B, C, D, then AC is equal to BD. Okay? But if I have my intersection point here called M, AM does not equal MC. Okay, just to be clear. What's that? I made it up. It's the point of intersection. Hmm?
If the two lines are the same, you put the dot in the center, how is it not the half?
So if we remove the trapezoid part, right? Just imagine there's a trapezoid around this. So does this from here to here look the same as from here to here? No, that's why. It's exactly how it looks. They don't look the same. So I can put a point of intersection anywhere. It doesn't mean that they're cutting it exactly in half. Okay? Now, the other thing here is base angles are equal on an isosceles trapezoid. So just like an isosceles triangle, we have congruent angles here as well. Okay? Now, do the diagonals appear to bisect those angles? Again, look at your picture carefully. Look at where you've drawn the angles and look at your diagonals. And think about it. Do they really look like it's cutting those angles exactly in half like it was for squares and rhombi?
No.
So I would argue no. Why? Well, this one looks a little bit smaller than this one, right? Okay. And depending on how accurate you're drawing, well, yours will look more or less. Okay. But they don't bisect the angles. Okay. The diagonals do not bisect anything on a trapezoid. Okay. So this is an isosceles trapezoid. How do I know it's an isosceles trapezoid?
There's two congruent legs.
Okay. So congruent legs and one pair of parallel sides. Okay. Isosceles, which means what? What does that tell us? Okay, the angles 2 and 3 are the same. So once we know 2, we also know 3. Okay. Now we're told 1 is 104. Does angle 1 have any relationship with 2 or 3?
Yes.
Supplementary 2.
Okay, so it's supplementary with 2, and so this must be 76. And once we know 2, we know 3. So we have 76. So the measure of angle 2, 76. The measure of angle 3 is 76. Okay, so that was the base angles. Now we've got something to do with diagonals, it looks like. So UW is 26. XV is 8x minus 6. How are UW and XV related? Okay, it's an isosceles trapezoid, so UW is equal to XV. And so we can write an equation, right? XV is the same as UW, so 8x minus 6 is equal to 26. So now we have a minus 6 out of place. How do I make minus 6 into 0? Okay, so add 6 to both sides. So we're left with 8x equals 32. Divide both sides by, not 4, by 8. And so we get our solution of x equals 4.